So here we're going to look at how to find arc lengths. And so before we get started, a quick reminder, how do we find the circumference of a circle? So the circumference of a circle is found by doing pi times the diameter. So from this example I've got here, that would be pi multiplied by 10. Turn it to a calculator, it's going to give us 31.4 centimeters. Okay, so the circumference, the distance around the outside of the circle, found by doing pi times the diameter. So what we're going to look at today though is we're going to look at what happens when we don't need the entire circumference. Okay, what happens when we only need a part of that circumference? So here, looking at the first example, I've only got half of a circle. Okay, so the other half is shaded out. We've no interest in that. So what we're going to do is we're going to follow the same pattern as we did just a minute ago. I'm going to find the circumference, which would be pi times the diameter. For this circle, it's going to be pi multiplied by 30. And so you turn to your calculator and you check, you get 94.2. But the thing is, I didn't want the entire circle, I just wanted half of it. And so when I'm looking at my circumference, I only want half of that. And so we need to find half of the circumference. So we get a half 94.2, and we get 47.1 centimeters. Okay, so remember I'm looking at the distance from there round to there. That's all I'm interested in. I'm not interested in the bit on the right hand side that's been shaded out. I just need to know the length of the curvy bit that I've dotted in blue. So let's have a look at the second example. Same idea. Okay, only this time I'm only interested in that quarter of the circle. So I would find my circumference, which would be pi times the diameter. In this instance, I've got pi times 2. So turn your calculator, 6.28. But I'm only interested in that top quarter of the circle. And I know it's a quarter of a circle. There's a little right angle there to tell me that there is 90 degrees. We'll come back to that in a minute. But just now I want a quarter of it. So a quarter of that divided by 4 is 1.57 centimeters. So again, this time I'm interested in that bit. So when we are coming to look at these, how did we come up with finding that it was a half of it? Well, what we're doing is we need to think about how many degrees we've got out of how many there is in the whole circle. So how do we find this fractiony bit? So on the first circle, section we were interested in was 180 degrees, that bit there, it's a straight line, out of 360 in the full circle. And when we simplify that fraction, we get a half. On my second example, section I was interested in had 90 degrees out of the 360 that there are in a circle, and we simplify that fraction to be a quarter. So, final example then. What about the arc length now? Well, now it's not particularly clear which part it wants and which part it doesn't want. And this is where we're going to start looking at the language that we used. So here we've split the circle up into two bits. There is this arc bit here, which is a smaller one, and then in a lighter blue, there's the big arcy bit around there. Okay, so we're coming off the line a bit so we can see where the lines go. So the big one is referred to as our major arc, and the little one is referred to as the minor arc. Okay, so when we're using the language in the questions, we need to be mindful that you'll be expected to know the difference between major and minor. Okay, which one is the big one and which one is the small one. So just now we are just going to find the minor arc length. And that is going to be equal to, well, it's going to be some fraction of pi times the diameter. Okay, I know that it's going to be a little bit of what the whole circumference would be. And so what we need to do is work out what fraction. So here I've got 45 degrees out of 360. I want to simplify that fraction down. It becomes 1/8. So my minor arc here is going to be 1/8 of pi times the diameter. So 1/8 times pi times 50. So turn to our calculator, we're going to do 15 times pi divided by 8. Now we get 5.89 centimeters out as our answer. So what happens though if our fraction can't be simplified? Right? Or what happens if we had that fraction but we weren't able to spot that it could be simplified? Now this is where our formula is going to come in handy. So in general, our arc length is equal to the angle over 360 times pi times diameter. Okay, and we, for convention's sake, sometimes we'll shorten that to be the arc is equal to, and we use the letter theta to represent the angle over 360 pi d. Okay, so even if we don't know how to simplify the fraction or join up our boxes, okay, we can still fit numbers in our formula regardless of what they're like.